In order to help us better understand IP addressing, subnet mask and subnetting in general, we need to know how to convert decimal numbers into binary and vice versa. We've already discussed the fact that with an IPv4 address, we have a 32-bit number broken into 4 octets, each containing 8 bits. Each digit in binary will be either a 1 or a 0. So with an 8-bit octet, we have 8 positions that will either be 1 or 0. And the easiest way to wrap your head around this is to create a table like we have here on the screen with 8 columns. Each one of those columns representing each of the 8 bits. At the top of each column, you see that we have a number 128, 64, 32, 16, 8, 4, 2, and 1. Binary is what we call a base 2 system. So each position here will be a base 2 numeral, where we take the number 2 and raise that to a specific power. The far right column will be a 2 to the power of 0. And in fact, any number raised to the power of 0 is going to be 1. So that's why we have a 1 in that column. Next, we have 2 to the power of 1, which is 2. We have 2 to the power of 2, or 2 squared, which is 4. We have 2 cubed, which is 8, and so on, all the way out to the last column. 2 to the power of 7, which is 128. So let's use the IP address 192.168.0.1 as an example. Let's start with the first octet in this decimal number, which is 192. We'll take that and we start on the left of our table. And then we ask, is 192 equal or greater than 128? It is greater in this case. So we're going to put a binary 1 in that position. We now subtract 128 from 192, which gives us 64. We take our 64 and we move over to the next column to the right. The heading of this column is 64. So we again ask the question, is 64 equal or greater than 64? The answer, of course, is yes. It is equal to 64. So we put another 1 in there. Now, we again subtract 64 from our column heading of 64, and that gives us a remainder of 0, which is what we want to get down to every single time we are doing this conversion. That means that the rest of our columns are going to contain zeros. So the binary representation of 192 is 11000000. This is our first octet expressed in binary. We can do the same thing with the second octet, which contains 168. 168 is greater than 128 for sure, so we put a 1 in that column. 168 minus 128 gives us 40. We move over to the next column, which is 64. 40 in this case is not greater than or equal to 64. So we put a 0 under this column, but it is greater than the next column of 32. So we put a 1 inside of that column. Then we do 40 minus 32, leaving us with 8, and we move to the next column of 16. 8, of course, is not greater or equal to 16. So that column gets a 0. The next column is 8. 8 is, of course, equal to 8. So we put a 1 in there, and we do our subtraction. 8 minus 8 leaves 0. So all of the remaining columns are going to be populated with zeros, giving us the binary number 10101000. That is the binary equivalent of 168 that we have in octet 2. The third octet is a 0, which is really easy to convert to binary. This is just represented by 8 zeros, which makes up our third octet binary value. And likewise, the last octet in this IPv4 address is also very simple to convert. You will see that it is a 1, which you can probably easily calculate looking at this chart. That is represented by the number 0000001. That's about it for decimal to binary conversion. Now let's talk about how we can go the other way from binary to decimal, just so you know. We can use the exact same table as we used before, And we can take any 8-bit binary number and place that into the column. So let's say that we have the example seen here. We have the binary number 100101110. How do we convert that to decimal? First, we place that number into our table, as we've already done here. And then we look at every column that has 1. Then we simply take every one of those columns that contains a 1 and we add those columns together. This gives us 128 plus 16 plus 4 plus 2, which adds up to 150. So that means that our original number is the binary representation of the decimal number 150. So it's super simple. Therefore, when you're converting either from decimal to binary or binary to decimal, creating a simple table like this one on paper will prove really helpful to you. And the more you do it, the more you will start to memorize the numbers. I know that probably that sounds absurd, but I promise you, if you do it enough, you will eventually get to the point where you can do lots of this conversion in your head rather than requiring pencil and paper or even the table. You begin to recognize the patterns. You'll be able to see certain binary numbers and immediately know what the decimal equivalent is.